Hello Internet, my name is Quinn and this is Blondihacks. I think a lot of beginners look at the compound on their lathe and wonder, how useful is that thing really? It just sits there, occasionally shows up to be all flashy for single point thread cutting, but otherwise it seems like dead weight. Well, it can do a lot of really cool things for you, and I'm going to show you some right now. The first trick for our humble compound is kind of an anti-trick. Delete it. That's right. Go ahead and mill yourself a block the same height. Precision is not super critical there because you can adjust the height of the tools anyway, and just replace the whole thing with a block that sits under your tool post. Why would you do that? Well, because on small lathes especially, the compound is by far your #1 source of loss of rigidity. So eliminating this can really step up the toughness of materials that you can machine and the depths of cut that you can take and so on. So if you want to do a lot of work in steel or tool steel on a smaller lathe, then try deleting this and see how much more success you will have. Well, okay, but that's not in the spirit of this video. Assuming you've decided to keep the compound, what can we do to get the most out of it? Well, first are some quality of life things. One of the annoying things about the compound is that it's tedious to crank it because of this small double-handled hand wheel. So get yourself some brass tubing or a pen cap or whatever, and you've got a nice speed handle that makes this much more pleasant. Now there are actually some Monarch lathes that have a power feed on the compound, which is an insanely cool feature. For the rest of us, we've got scraps of round bar welded into a T on an electric drill. Poor man's power feed. Now here's a real old school trick. Angles are our best friends and worst enemies. They magnify error because they effectively act as a lever on that error, but looked at the other way, they also allow us to dial in very small moves. And that's where the compound comes in. Let's say I've just turned this diameter and I need to really nail this dimension. So how am I doing here? Well, I'm 1/1000 over. So do I dial that in with my cross slide and hope that I don't overshoot it? Do I get out the emery paper and sand that all the way down, which would take a while? My cross slide increments are 2/1000 because this is a direct read hand wheel, so every tick takes 1/1000 off both sides of the work because it's spinning. It's 1/1000 of travel on the lead screw, but 2/1000 of diameter reduction. So to take 1/1000 off the work, I'm looking at trying to eyeball a split between those two lines. I don't love my odds doing that. Before you start a cut like that where you know you're going to need to nail the dimension, set your compound to 14 degrees. Why 14 degrees? Because the sine of 14 is 1/4. Now the hand wheel on my compound is indirect read. It's measuring the travel of the compound along its axis. So if the compound is at a 14-degree angle, then 1/1000 of travel on this angle, do the trig, sine of 14 degrees, 0.25, that's 0.25 of travel this way. So that's effectively a 1/2 diameter reduction on the work because you're going to be cutting that on all sides. So setting this to 14 degrees makes your compound into a 1/2 feed. Now make sure you take up the backlash in this before you do your cut, of course, which I have done. So now I can dial in 1/1000 on that hand wheel. On that cut, it didn't even look like anything happened, but the micrometer tells no lies. So just like that, we've taken off exactly 5/10 off of that dimension in a very low risk way. One more pass like that, and this dimension will be dead nuts. So leveraging a little bit of trigonometry, we can make very small moves on the tool with the compound. Editor Quinn here. There's an additional subtlety here that may not be obvious. The potential error of this method is also much lower. If I overshoot the tick mark on that compound by a little bit, I'm only overshooting the dimension by a tiny bit compared to using the cross slide where if you overshoot a little on the tick mark, you might be totally blowing that dimension. And this is something that the old timers used to do all the time. You don't see it that much nowadays with DROs and such, but it's an awesome trick for those of us on low budget machines. Now we all know the compound is used for single point thread cutting, and I did a whole video on that process if you're interested, but real quick, if you've ever wondered why do we feed with the compound when single point thread cutting, you can do a very simple little test to demonstrate to yourself how that works. Put your fishtail gauge on the thread cutting gauge, set your compound to 30 degrees for some lathes or 60 for Asian import lathes, and then crank that compound back, and you can see what happens. The thread cutting tool is moving at the exact angle of the thread that you're going to cut. And what this means is that you're only cutting on the front side of that tool. You're not cutting on both sides of the tool, and thus the compound lowers tool pressure for you. Now let's say you've just turned this part and you want to put a big old taper on the end of it, something bigger than a chamfer, which you would just do with a file or a chamfering tool. Now in something soft like brass, well, you might just grind up a form tool and push it straight in there. Job done. But if you're working with, say, steel or tool steel on a small lathe, you don't have the rigidity for a form tool in a material like that, or if you need a very, very precise angle on that taper, well, form tools now are probably more trouble than they're worth, may not work at all. That's where the compound comes in. Now, of course, you can visualize if I move the taper that the tool is going to follow that angle relative to the work. So you can kind of intuit roughly what's going to happen here. There's a couple of tricks though. The first is that there's always two different ways to get the angle that you want. So we want to cut an angle like this on the work. So we need the compound to match that angle so that the tool is sliding at that angle. So I can do that by turning the compound like this, or I can go all the way around the other way and do it like this. Which one you use just generally depends on the setup, which is going to be less in the way and so on. Doing it this way often seems more convenient, but be mindful of where your hands are relative to the chuck, because your hand wheel on the compound's getting pretty close to the chuck. And your decision may also be affected by the markings on your compound. The angle markings may only cover a certain range, and so you might have to rotate it this way in order to see the markings. With your compound angle set though, your tool is going to be in some crazy nonsensical place. Now what do we do? Well, your tool post is typically going to be set in a small range relative to where your compound normally sits, so of course now we have to adjust it to suit where the compound now is. So you're going to rotate your tool post around, but what angle should you set it at? It's kind of hard to visualize, right? Because we're cutting a taper, so the angle isn't clear. And the answer is, it's the same as when you're turning. When you're turning, you want the tool square to the work. Same here, except that the work is now at an angle. You want the tool square to the surface that that tool is going to be creating. So all we do is imagine roughly the angle you're going to be at and rotate your tool post until it's going to be square to that surface. And you don't have to be super accurate about this, just eyeballing it is good enough as long as you're going to roughly have the 10 to 20 degree clearances on either side of the cutting point as you normally would when turning. You're going to be good to go. I'm ready to start turning my taper now, and the process is the same as any normal turning operation. You touch off on the work, move clear of the work, dial in some depth of cut, and feed across the work. But all of those operations are a little mind-bending now because we're at a funny angle. So roughly what you want to do is touch off on the outermost surface of your taper, which currently is this corner. Whatever the corner of the work is right there, that will soon become the first cut on your taper. So you're going to position the tool right there, and you can touch off on that and then crank the compound back to be clear of the work, and then you dial in depth of cut with your cross slide as normal, and then you feed across with the compound. One more time so you can see the hand wheels. So I'm going to use the compound and the cross slide to just get the point of my tool right on that corner there, and then I'm going to feed in until it touches off, and then I'm going to wind back out of the work with the compound, feed in my depth of cut with the cross slide, and then I can wind across with the compound and make my cut. For my touch off, I've got the compound all the way to one side because you will run out of travel on small lathes on the compound. So it's helpful to make sure that you're going to have room for the cut that you want to make before you start. Now if you look closely here, you can see some striations in the surface that are regularly spaced, and that's the effect of feeding by hand with the compound. Because that tiny little hand wheel is kind of awkward, your rotation tends to be kind of herky-jerky, and so you end up with these little pulsations on the surface finish. Usually you can't feel them, but they are usually visible. If you want to do better than that, then rig up some sort of power feed for your compound like I showed earlier. But hopefully with that operation, you could see how if you're doing something tough like tool steel and you wanted a taper, you'd never be able to do it with a form tool. But the reason you can do it with the compound is because the compound transforms this taper into a single point cutting operation. And so we get all the advantages of very low tool pressure that you get with all single point cutting operations. And as I said, the other advantage of single point cutting a taper is precision. With a form tool, you have to maintain precision through the grinding of the tool bit and the alignment of the tool bit to the work, all of which is quite error prone. However, when you single point cut the taper, the lathe is maintaining your angle for you because of course the slides all move exactly at the angles they're supposed to, unlike your grinding habits. Now I just eyeballed that using the markings on the compound, but let's see how close we actually got. I couldn't get the protractor in around the chuck jaws here, so measure it out here. And survey says that's an 88 degree included angle, which means that we are at 44 degrees on that. So, for eyeballing it to 45, not too shabby. That's about what you can expect. But what if you need more precision than that on the angle? Well, just like anything else, when you really need better accuracy than the hand wheels can give you, you start ignoring the hand wheels and you find some other way to line up the slides. So one way is just simply to use like an angle block and check the angle against the face of the chuck, or if you have an accessible reference surface on the work, sometimes that's even better. But all you got to do is get your reference block in there and you can set the angle then of the compound from here. So right now, I can feel that 1 degree rock that's in there because we have it set at 44 degrees. If you can get some light behind the angle blocks, that's ideal because you'll see more of an error than you will be able to feel. But when space is tight like this, something that also works is just get something bright white behind there. And that white paper will reflect enough light back up at you that you can actually see the gap in there. Your eyes can see it better than the cameras can, but it's pretty clear. So then loosen up your compound a little bit and just tweak it until that block seats in there tightly, tighten it down, Bob's your uncle. And this will get you to within better than a degree, but what if you need even more? As with any setup, the next level in precision is, of course, the indicator. So you want to run a dial indicator on something that will tell you when the angle is correct. But how do you do that? Well, you need something that matches the angle that you're trying to match with the compound so that you can run the indicator along that angle, and then when the indicator doesn't move, the compound is parallel to the reference angle, and now you've got the compound at the correct angle. That precision reference angle could be something like a ground angle block, or it could be a sine bar with a stack of gauge blocks. Those are a little tricky to set up sideways for the compound, but it can be done. Quick sidebar here, if you don't have a reference angle available, there is another way to do this that I didn't demonstrate, which is to put an indicator on the slide that's going to be doing the cutting, and then put a dial test indicator on the stock, as I'll be demonstrating here in a moment. And what that allows you to do is measure a specific fixed distance on the slide that's going to be doing the cut, and compare that to the offset to the stock that's created by the compound, and you can do the trigonometry to figure out how much that dial test indicator should move for that given distance of carriage travel. This isn't really a video on cutting tapers though, so I didn't want to go into all the gory details on different ways of setting up slides to do all of that, but maybe in a future video. But even better is if you can find something round that matches the angle. For example, if you're trying to turn a Morse taper angle, find something that has that taper on it, put it in your chuck, and now you've got your matching angle. This dead center happens to have a little straight section on there that I can clamp on. Of course, you can't clamp anywhere back here because it's an angle. It's kind of the whole point. A 1, 2, 3 block will get us in the ballpark here and save us a whole lot of tedious indicating. The indicator is set on the compound and it's reading on my taper there, and I can preload with the cross slide so I don't have to move the compound to do this. And now I can start moving the compound, and you can see using that 1, 2, 3 block to get us in the ballpark. Yeah, we're within maybe 4 thousandths here, so 5 thousandths over the whole length. So not bad, we're in the ballpark. So now I'm going to use my tappy tap tap hammer on the compound and get this thing dialed in just like any other indicating job. If you were setting up stock on the mill, this is the same process. It's a little bit mind-bending because we're indicating on something angled, so you just got to remember that this is straight in the compound's worldview. It's like relativity, but for compounds. After a couple of rounds of tappy tap tap, you can see that we're now within half a thou. There's quite a lot of wiggle in the travel on the ways on this compound. The gibs are, not perfectly adjusted or frankly particularly well made, but you can see that we're easily within the travel precision of the compound there. So that's certainly close enough that you could turn a Morse taper. It may or may not work with that amount of error in it, but you're certainly within surface grinding range then if you wanted to then grind in the perfect fitting Morse taper. For this next trick, go ahead and set your compound parallel to the cross slide. And now we have two hand wheels that control the tool in the same way. Why would we want that? If you're making multiple parts or you have multiple features on the same part that need to be the same diameter, setting up the compound like this gives us a bookmark. It allows us to get back to the exact same position on the tool in a super repeatable way. You're going to touch off on the work, then you're going to zero the cross slide, and then you're going to make all of your cuts by dialing in depth of cut on the compound. So make some passes, dial in the compound, make some passes, check with the micrometer, and once you're there, you can stop. Now you can wind out with the cross slide, move to a new location on the part or put the next part in, whatever you're doing, move the cross slide back to 0, and that tool is now exactly where it was before. So you can recall a previous diameter setting on the tool by using the cross slide as a bookmark and feeding with the compound. All right, now set your compound parallel to the carriage. Why would you ever want to do this? One reason is that some lathes, especially less expensive ones or some very old lathes, don't have a lock on the carriage. And it's very handy to be able to lock the carriage to, for example, do very precise shoulder cuts, things like that. So what you can do with the compound in this position is you can use your half nut lever to lock the carriage to the lead screw. Make sure your lead screw is disengaged, of course. And now the carriage can't move. Now you can dial in depth of cut for a shoulder or other feature using the compound, and then you still have access to the cross slide to cut your feature. So if you don't have a lock on your carriage, usually they're not that difficult to add, and it's a very good thing to add, but in the meantime, you can use your half nut as a lock with the compound set like this. Another advantage to this compound position is that it allows you to extend the reach of the carriage, because now you can run the compound in like so, and sometimes this will allow you to get in to a tricky spot on a part where you might not have clearance under the carriage, say near the faceplate or other obstructions that might be down here on some chucks. Or conversely, if you need to get the carriage in real close, you can buy yourself clearance on the tool post by winding the compound the other way. So all depends on your needs, but this compound setting will allow you to effectively shift the carriage in space without moving the tool, which often solves a setup problem. Don't underestimate the compound's power to give you more reach, especially on small lathes, and especially when working close to the maximum swing of your lathe. Something the advertisements never tell you is that the swing of your lathe might be technically possible to achieve, but your tool can't reach it, so what's the point? In this case, technically I can swing a 10-inch part in here, but there's no way I have that kind of room on the tool post. Unless you swing the compound around. You can go all the way to the extreme like this, or to a 45-degree angle, whatever works for the situation. And now I can actually wind the compound out quite a ways. Now look how much more reach I've got. Now we've got some swing. So if you're turning flywheels or other large diameter parts on the faceplate, for example, running the compound in reverse backwards like so can really buy you a lot of extra reach on the tool post. I've found on a small lathe, this trick is often the only way to get the reach that you need. You can also use left-handed boring bars and some other tricks to gain reach, but don't forget the compound. Speaking of the faceplate, the compound is often crucial for those setups because the faceplate goes all the way down to the ways, which means there is not clearance for the carriage to get up under it like it can with a chuck. And you might not realize how often you need the ability to get the carriage under the work holding in order to get the tool in there. As soon as you go to the faceplate, suddenly you realize how much you were counting on this clearance under here. And once that's gone, the compound is now your friend, because now I'm in as close as I can be with the faceplate up against the carriage without touching it, but now the compound is what allows me to reach in there and get the operation done. That little bit of travel on the compound for reaching in close to the work is often a lifesaver. Well, that's my little tour of the compound. You can decide for yourself if it's worth keeping on your lathe, whether the loss of rigidity is worth all the little tricks it can do. I think I'm alone on Machinist YouTube in that I really like my compound, so I keep it on there. I find all sorts of uses for it, like a few of the things that you've seen here. And I've probably missed lots of tricks, so whatever tricks you have for the compound, put them down in the comments below. And thank you very much for watching. If you like this content, throw me a little love there on Patreon. The patrons are really what keep this content going. I couldn't do this without them. And I will see you next time.